Good morning, good afternoon. Welcome to another Sedaru Live. I'm Adam Simonson, Director of Enterprise Solutions for Sedaru. I'm with Kevin Koshko, our Chief Product Officer. Kevin, how are you today?
I'm great, man. How are you?
I'm doing good. I'm doing good. Are you ready to do a deep dive into some hydraulic modeling here?
I am, and it's, my background isn't in modeling, so I'm excited to see kind of how we can do this for someone who's not an expert like myself. So I think there's
Sure.
some cool things that can be done.
Absolutely. But you do have a background in taking really hard technical things and making them easier for everybody to use, though, right?
Yeah, I'll give myself some points for that. So.
Okay. Cool. Cool. Well, welcome everybody. Glad you could take some time out of your day to join us today. I think we're gonna. This should run about a half hour, maybe a smidge longer, depending on how many good questions you have. If you haven't joined us before, familiarize yourself a little bit with the interface for the webinar. There's a button for you to be able to ask questions. So if you go in that Q&A panel, you can fire up questions as we're talking and going through things. It's always more fun when we get to hear exactly what you guys are looking to see and want to know about. If you haven't already, take a moment and go follow us on social media or like us or whatever the right action verb there is for the various social media platforms. If you get bored in the middle of the webinar and you find yourself staring at your phone, at least you could sign up to get more news from us from social media here. So look for us on Twitter and Facebook and LinkedIn there. And Kevin and I also have a podcast that we've been doing. I don't know, every month or so we manage to get an episode together and chat about things going on in the industry, places we're traveling to, going to see, and whatnot. So that's usually a lot of fun. Kevin, when are we going to do the next podcast?
Gosh, I don't know. We did our ACE wrap up a few weeks back, so I think we need to do something real soon. It's usually kind of we'll do a seasonal thing, depending on kind of what's going on. If it's Halloween or if we got shows coming on or whatever's going on. But yeah, I like our podcast because I don't know of any other like industry kind of chat forum where a couple guys sit around a virtual campfire and talk about the water industry.
Right.
So I'd recommend it, and we always have a good time. So
can we do the next episode about your non-kid vacation to Cabo?
I think that's a great idea. I think there's a lot we can cover that is not water related, but that's okay. We can take a little break from that too.
Mostly cerveza related.
Yes, I mean I guess there's a lot of water in that, so I guess we can chat about that then.
Cool. Well, let's jump into some things here a little bit. I'm gonna fire up on the screen here. You'll kind of see what we call the Sedaru modeling interface. And a little background for folks that don't know. Our company started life in 2004 with the name ID Modeling, really as a consulting firm focused around doing hydraulic models for folks. We're now known as Sedaru. But the genesis of Sedaru, a lot of people might not know, really actually came from hydraulic models and this idea of how do we both make it easier for folks to do a hydraulic model and to run the hydraulic model, and then also to really be able to help connect data systems together. And for those of you that are really familiar with modeling, when you want to go build a hydraulic model, you need data from all over the place. You're looking for GIS and asset information. You're looking for demand and meter information. You want SCADA data that you're going to need to calibrate it. You're pulling data from fire flow tests and all of these places. And you typically go, there's quite a few consultants I noticed on our webinar today that have histories of building models. You go and you show up at a utility ready to kick off your project, and you're like, okay, I'm here. Let's go. I need all this data, and then what happens, Kevin? Usually you're sitting there, you're like, well, this guy's got this, and that guy has that. And so you end up, it becomes a process in and of itself to just do it. And that's really where the idea of Sedaru was born from, of being able to pull all that data together. That whole C data run, that's where the Sedaru name comes from, was really all born out of this idea of hydraulic modeling. So what we've done with your usual hydraulic modeling, and what Sedaru modeling is designed to let you do, is to take the most common things you're going to use your hydraulic model for, and to simplify them and make it so that you don't have to be a hydraulic modeler. You don't have to be an expert in the mechanics of pushing the buttons of hydraulic modeling software. And that's kind of the interface that you see here in front of you.
Yeah, Adam, I was going to ask, like, where's all the buttons? Isn't a hydraulic model supposed to look like the interior of a 747 cockpit?
It's kind of evolved that way through the years. You're right. I mean, there's a lot. That's the way, and I like our take on it because we've refocused the whole thing and tried to streamline it down as much as possible.
Yeah.
So let me walk through a quick example here to kind of show you how some things, and then we can kind of deep dive into some other sort of features and pieces of it. So one of the most common things that folks want to use their hydraulic model for is to run fire flows and to check, developer requests, right? Every water utility in the world, or at least in the Western world, the developed world, has a process that they go through when they get a developer request, and how do they evaluate that and decide what needs to happen. And part of that is usually checking fire flow. So what's really neat here, I can come and I can use the map and I can zoom into whatever area that I want on here, and I can just pick a spot on the map. I'm going to pick this dead end here. And let's say I have a request that I want to be able to see what I can do for fire flow here. So I click on that, and you see I have this junction selected. And if I come here and I go to the next button here that says simulate, it gives me a bunch of options for what I want to do. And I can essentially choose one of those options from here. So from here, I want to just be able to meet fire flow. So I'll click on that. And then it has this little handy flow chart that really walks me through the process. So right now we're looking at a little over 8 GPM is the normal demand that's there. But I want to see what happens if I want to get 1,000 GPM out of this location. So I'll go ahead and I'll just put 1,000 in there as a number. I'll click done. And then it tells me what I'm doing up here. And then I just go ahead and click run simulation. What's cool about this is it's using the EPANet engine to run that simulation. And it's telling me, and it's giving me back the hydraulics essentially right away. So it's going to spit out for me this hydrant curve. And you see along here, it's telling me exactly what I'm able to get here. You see right here at 20 PSI, I can get over 1,000 GPM. So it's really laying out for me exactly what it should look like. And it's giving me that full hydrant curve really within a couple seconds of me being able to run the model. I can come back in here, and now I can view the map as well too. And so what the map's going to now show me, it's now color-coded everything on the map for me. So I can actually come in and see, if you look here, everything that's in orange is in this sort of 25 to 50 PSI range with that demand that's on there. And I can see the results pretty easily. My velocities are color-coded. You notice this green pipe, the green pipes over here, are ones that have a little bit higher velocities. The blue pipe are all pipe with less than a foot velocity in there. So I very quickly can kind of see the results and say, okay, hey, if I needed to get 1,000 GPM out of this location, that's pretty doable.
Well, let me ask you this. So that seems pretty cool, but what happens if we lose supply to one of those feeders going into that neighborhood?
Yeah, I mean, common too, right? Like if I'm evaluating scenarios sometimes, or if I'm evaluating shutdowns, I might want to say, hey, I need to take an area out of service, but I still need to check fire flows. I still need to maintain sufficient fire flow protection. So let's say maybe this north end of this development here, I'm going to lose service in one of those pipes that's in here. So I'll come in, I can just click on that pipe, right? I can see the details of it if I want, right? So I can come in there, I can see what we're looking at. It's an 8-inch pipe. Basically all the data from my model is going to show up in there if I wanted to look at that. But then once I come over here and hit simulate, you notice up here it has a little thing where it says more changes. So now it's going to let me make more changes to this scenario that I'm working on. So since I have a pipe selected, here's my options that are in front of me. And we're just going to go ahead and close this pipe, bring it right out of service. So I'll go here and I'll just go ahead and I'll click close. And then I'll click done. And now what we're going to do is rerun the simulation. And so it's going to update my fire flow for me. And now this is interesting when you look at it, right? You notice that this label here shows up right in red. And it's basically telling me at 20 PSI, I can only get 875, GPM in here.
Okay, so we didn't meet that fire flow that we needed, right? It was supposed to be 1,000, and we're a little short, right? So that's why
Right.
it's red.
Exactly. Exactly. And you notice this trend up here. It gives me some other information. So again, it's trying to really simplify it. So it's telling me right here in the upper left, the flow at 20 psi is 875. My static pressure, we're drawing it way down to zero, which would be a problem. The residual pressure, basically at the node adjacent to there is only going to be 15 psi. And then it's reminding me what our required minimum pressures are and what our flow is. And so I can see, right on the graph here that I've got an issue.
Yeah.
And then if I go back to my map, I'm going to be able to, look at the color coding there as well too. And I'll zoom out a little bit. We'll see what the rest of the system looks like here. And so now you look, as I get even farther away over here, over to this part of the system, which is farther away from the sources here, you see lots and lots of problems sort of showing up in here as well too. So clearly having, that kind of fire flow coming in here causes all kinds of problems. And then within here, within that area there as well too.
Yeah. Is there other impact to that then that we could see?
Yeah. Yep. So when I come up with the impact tile, I really like. So one of the things that that happens when you're running a lot of the traditional hydraulic modeling softwares, I have to spend a bunch of time figuring out kind of how to interpret my results a little bit. And what we've tried to do here is to make it really straightforward for you to see what is just the biggest impact. So just really putting it out in front of you and showing you, okay, here's really the key problem, the key issue here. And so what you see here, you see these red dots kind of flashing. That's showing me what is the top 10 nodes or junctions within this model that are going to be affected by this particular item here. And as I move my mouse over here, you'll see the red dot kind of move and change.
Yeah, it's kind of pulsing there. Yeah.
Yep. And that lets you kind of focus in right on that and see exactly what the issue is, see exactly, where the problem is. And so I can do all this for, pipe velocities, pump flows, tank levels, everything to kind of just make it, again, really easy to interpret your results and to understand, like, do I have a big issue or do I have a little issue? And sometimes if you have a big issue, you might go, well, I really need to dig into this. And that's where you're going to pick up the phone, call the engineer and have them really, kind of maybe dig into something or have them start doing design alternatives for you and some of those pieces in here. I also, go ahead, Kevin, sorry.
Yeah, I was actually going to ask, so what about can I give that like a report to a contractor or other, like maybe not even like a hydraulic report, but just like the simple fire flow, is there like a one pager or something that we can get from that?
Yeah, good question. So you come over here to the share tab, and now what I'm going to see is some different reporting options here. So you've got the output report and the simulation report. These things are for folks that want to dig into the deep details of modeling. That's going to actually give you all the EPA net output on there. So you can take a deep dive into stuff. If for some reason I put values or parameters in here that made it so that the model wouldn't solve or did something crazy, like I could troubleshoot it from there and do that kind of stuff. But for 99% of people, what you care about is the results coming out of this, right? And so I can just go here to the summary report.
And there's even there's an even more simple one for fire flow report as well, right? Just so I'm clear.
Yes,
right?
Yeah, correct. So I can go here to this example here. I'll save that. Give it a place where I want to put it up here. Give it a name. I'll save that. And then it's going to actually go ahead and generate this report for me. Spit that report out as a PDF that you can go, like you said, anybody can look at it. You can go pass it on and be able to see all the details of it here. So we'll let this generate, and we'll take a quick look at it here. Let's see. All right, cool. I think that report's done. So I'll pop it up here real quick. And so now I get to see is kind of the same thing. Like, where were we looking at? What was the area? What was the system demand? you know, what steps did I change in here? You know, what kind of results did I see? And I can sort of scroll through all those, and you've got all of that kind of tidied up in the report for me to see the details of everything. So that PDF becomes really easy to kind of pass on to anybody you want, any, you know, developers or just internally for that matter, as well too. And then I think also you were referencing here, Kevin.
Yeah. There's maybe just a Fireflow report if I don't need all that other stuff.
So if I just want to look at the Fireflow report example, I'll come here, I'll create the report. Oops. We'll save that one out as well here too. So you got a couple different options of ways to be able to kind of, like we said, dig through the data, and then to kind of quickly be able to see the results of that show up as well. So let me just pull that up real quick so people can see that. Give me 1 second. So here we get to see that same thing, but now with the hydrant curve kind of being the star of it. And so I can, you know, like you said, I can see exactly what some of that stuff would look like, and have all that detail right there for you. So really trying to simplify some of that stuff.
Yeah, I think we have some utilities that use this like for contractors. So when a contractor wants to build, they'll go in and you know, create this Fireflow report based on the address, and then they basically kind of staple that to a letterhead, and this is kind of that final report. So that's cool.
Right. There was one of the questions that just came in, which is a good question in here too, is can I show like my actual hydrant layer here from the GIS, which I can. So you notice up here in the upper left, I've got this ability where it says model and GIS. I can actually come in here and turn on my GIS within here. And let me zoom in here a little bit. And so now what you'll see is actual locations of where I have hydrants in the system overlaid on the model itself, nice. Along with all the granularity of my GIS data in here. So I can see all of that information directly within here. So one of the classic problems that you have when running hydraulic models is, how do I keep my sort of model integrated with the GIS, right? And there's a lot of workflows to do that. A lot of it is built off of how you handle your GIS maintenance and how often you want to update your hydraulic model. One of the things we do to help support that, though, is to just make it really easy to sort of look at your model in conjunction with your GIS, and to be able to sort of overlay the two really easily, look at it when you want to, and then when you don't want to, you can sort of turn it off pretty easily. What's
does
also really
does it have to be one-to-one with your model? With GIS?
No, I mean it doesn't. So I mean it's just spatially looking at it in the same way. So I mean there's a whole side of things that we could get into, the benefits or the downsides of trying to maintain one-to-one relationships between your model and GIS. And generally it's beneficial, but like I said, it takes work. So what you hate to see is somebody saying, well, I can't use my model because it's not perfectly matched up with my GIS, and I need to know this. So this gives me the best of both worlds right within here. If I come here, if I then kind of toggle over here, I'm gonna go to our Omni interface, which some of you might be familiar with, right? And so this is really like the main area within Sedaru where I see data from all these systems across everywhere. So what's cool about this is I can run my modeling, be running my modeling piece, looking at something, seeing what's going on, seeing what's happening there, and then I can sort of toggle over to this view here as well too, where I can come in and be like, what's this? We've got valve exercises that are scheduled out here, or let me see what is actually going on here with this particular customer, this particular meter, what's going on here. And so that idea of trying to make your model that much more effective right? And being able by being able to combine it with all this additional information, um, is really valuable in there.
Yeah, I noticed in the modeling side, it would show like little icons when you turned on GIS.
Mm-hmm.
So
Yeah, correct.
what was that all about?
Yeah, same thing. So if I even back here on the model, when I turn on the GIS, right? So I'll shut this off, and then just so you can kind of see what Kevin's talking about, I come in here, and then I can turn that on. So what you're actually seeing when I do that, you're actually seeing all the information from the core of Sedaru showing up there. So I can see, recent or scheduled tasks that are showing up at any of these particular locations in here.
Yeah, that's cool.
I can see all that, and then if I want to have more detail about it, I just come over and back into my Omni interface, and then I can navigate, everywhere around there, and to be able to do that. So it's really, trying to do a good job at merging a lot of those, those pieces together, and to really try and help you, even if you don't have that perfect one-to-one relationship between the model and the GIS, to give you a platform where you can interact with all of those things really pretty cleanly. Let me walk through a couple other examples here for folks so you can kind of get a feel. You have this ability, so I think most people who have dealt with models have this understanding of scenarios. And so essentially what you're able to do is to bring in a scenario from just about any other modeling package and bring that directly into Sedaru. So I'm actually going to bring in what we call an extended period simulation, or an EPS simulation, into here. And you notice there's a few different ones listed in here, right? So you can sort of have the ones you want available to you, have those in there to show. And I can come in here and I can do similar sort of things in here. I'm not going to run Fireflow off EPS, but I can run any sort of kind of similar setup that I want. So maybe here I'm going to just select one of these nodes that are in here, and I want
real quick question, Adam.
Yeah.
What is EPS?
Yeah. EPS is extended period simulation. So instead of just looking at a snapshot of what's going on, it's saying I want to look and see how the system behaves over time. Right?
Okay.
And so that means when I look at the results on things, here I'm going to change this demand here to from 5 or so GPM to 50 GPM, and I'm going to run the simulation. And I believe this is a 24-hour simulation that's running in here. And so now it's going to show me how does the whole system behave over 24 hours. Okay, so and let me be able to kind of see those results that are in here. So I get a little message down here that the simulation ran successfully. And then if we want to drill into the results, so maybe we want to look at let's see. So on the impact, it shows me, I get kind of minor changes to things, right? Nothing overly dramatic in here. But I could go to one of these junctions and let's look and see how does the pressure behave in that particular junction. And I'm just going to take this Fireflow curve out of here. So this is a little bit bigger. So I can see now, that with that particular demand condition, the way that this is set to behave is that the pressure is going to be down here around 65 psi, and then as we get to the middle of the day, it's going to go up higher, and then it's going to go down essentially. It keeps the same demand pattern. So what happens, Kevin, is that in an extended period simulation, there's usually a defined pattern for how the water gets used. It usually peaks in the morning and peaks in the afternoon, kind of. And so it follows that. And so you can do that and kind of evaluate the results throughout my system and see how these various pieces behave. And really same idea in terms of wanting to just be able to kind of navigate the results and move around the system. I can do things. I'll show you here. I think I've got some tanks and pumps in here somewhere. And I can search for things in here too. If you're navigating your system and you can't remember, you can come up here and use the search bar and type in things. But I want to look at this particular tank that's here. So we'll come in and we'll look at this tank, and the same idea. Let me get rid of this graph. And so now we can see how that tank behaves throughout the course of the day, right? Nice. So I can come in and look at these things and see, when it should be draining or filling, What does the average sort of look like? All those pieces of, in there as well. Similar idea when I get into the pumps that are in there. I can look at that information. You'll also notice here, if I come over to simulate just to sort of show, I can do stuff with these pumps as well too. So I can take, various pumps that I have in the system and turn them offline and sort of evaluate scenarios from that perspective as well too. So a lot of flexibility to kind of run some of those different changes that are in here.
What's that slider on the bottom?
Good question. I forgot about the slider. So the slider just basically, from a map view, is going to let me look at the results of my simulation with that color coding, but review it over time. So I can come back and pick up time, say, hey, 2 in the morning, what is it going to look like? And if I play it, it will slide along. And at each time step, it's going to go ahead and update for me and show me, what's going on, what's happening at that particular time step. And let me get an overview of the system and kind of see exactly what's going on. And I can, if it moves a little slowly for me, it's like, okay, that's what it looked like now. Let's see, what does it look like, at 10 o'clock? And then what's it look like at 6 o'clock? And be able to kind of navigate the results that way again too. So, and a lot of what you're trying to do with some of these things is to quickly wrap your head around things. Quickly wrap your head around what's happening and what's going on, in the system, and to, and to make some quick assessments on things. Does that kind of make sense, Kevin?
Yeah, it does. That's really cool.
Cool. So a couple questions we'll try to field on some of this stuff, and and as you guys have other questions, just certainly let us know. There was a question about units, whether in the reports. So I mean, the units are kind of built into the reports at the moment. Whether you can go from GPM to FPS to feet per second. You'll notice though, like color coding rise right here, right? Like when we're talking about feet per second, which is a velocity that when we're looking at velocity in here in a pipe, it's pretty standard definition. GPM, is when we're looking at things at a more macro level. So we've tried to just stay with a lot of industry standard stuff to keep some of that stuff as straightforward as we can. Reports in Excel. Right now, these other reports are basically set up in as PDFs. When I'm looking at other reports, Kevin, can I get them out in Excel? I can't remember.
I
can.
Yeah.
So when you want to like drill into individual nodes or junctions or some of these things, like if I wanted to get the breakdown of these tank levels, step for each time step in Excel, I can go ahead and get that data out of there that way as well too. And there was a question about the FireFlow stamp. Is it sufficient quality for a PE to stamp them? Which is a really good question. And really, so I'll tell you this: the FireFlow report was built for utilities as a way of being able to do that, right? So that they can run their assessment, run their analysis, and do it. So it does have, it's using the EPA net hydraulic engine. It has all of the sort of standard pieces there that go into it. The trick in understanding, what to do with some of those things, obviously, is where did my model come from, right? What kind of, understanding like the scenario that I'm playing in here, is that the right scenario, right? Am I, should I be running my FireFlow analysis on an average day, on a max hour scenario? These are all the sort of things that we talk about from like a PE engineering perspective that you really certainly want somebody thinking about with the right qualifications to do. One of the things that I like about what we're doing with modeling and how I have seen it used by utilities is you might have your workflows for how you define your approved hydraulic modeling scenarios. Those scenarios themselves show up in here. You're publishing them into here. So you have sort of control over what scenarios would actually be available to people to be able to what would actually be available for folks to be able to use there. And so I think every time you're using this, or you're setting it up within your organization, like any piece of software, you're kind of defining what are the workflows, what are the ways that we're going to use it, what's the way that we're going to have things happening in there. There was a question too about, can we add pipes in here? At the moment, no, you can't add pipes in here. There's a fairly healthy list of some new features and developments that you're going to see us rolling out with Sedaru Modeling, over the next 12 months. That's one of the things in here. We just recently updated all the back-end infrastructure on this, which was really pretty cool. I mean, what we did is that we made a whole bunch of performance improvements, and it's been really exciting to see some of our largest customers that are running modeling, some of the really big utilities around the country. They can now run this model. It runs pretty much as fast as the EPA Net Engine runs, and so you're talking about being able to run 20,000 pipe models that run in 30 seconds kind of thing.
Yeah, that's for a web-based model. That's super impressive if it can go as fast as like a client app. So that's pretty sweet.
Yeah, absolutely. And because that's a good point. I didn't even really mention this, and I forget about it sometimes, that this is a web-based application that we're looking at, right? So you're not tied to now running your model from a desktop piece of software, right? And so you can license this for your organization, and you can be in a meeting and somebody has a question about something. You can open up your laptop, fire up the web browser, run the model, and look at the results on it. Kind of do those things instantly without having to be tied into here's the computer that runs the hydraulic model, and being able to and doing that. So it really kind of changes the paradigm in there. If there's another question about like what happens if the model doesn't run, which happens sometimes with a hydraulic model, depending on the criteria and some of the things that you have in there. And really, that's where when we get into these reports here, the output report and the simulation log, the first thing that's going to happen, actually, you're going to get a message down at the bottom. So down here where it says simulation runs successfully, you're going to get a message that's going to tell you the simulation didn't run successfully. And then you're going to get, I can actually dig into these reports if I want to and say, okay, what happened? Because it's really the same debugging tools that you would have in any modeling software. It's going to walk me through the simulation and point and say, okay, hey, here's where this is. Here's where this is not. Here's where it failed, right? Here's where it didn't balance, or any of those sort of details in some of those things. Let's see. Kind of plowing through some questions. Still plowing through questions here. A lot of good questions folks are asking. I like it. So one of the questions was essentially like, how do I manage model updates coming in here? So what's pretty neat is I can essentially, as I am managing my model update and whatever my existing workflow might be, so that might be coming out of like Water Gems or InfoWater, or I have a consultant that's just doing the modeling work for me and passing on to me. Essentially what you're going to do from there is export that updated scenario as an INP file, which is that EPA net file. And then essentially you can just come here where it says upload an EPA net file, and I can basically bring that file right into here. And bring it right into there, and then we'll process it and will become available, and you can run that directly from there. And so we've helped folks kind of help define their workflows around this, because this question comes up quite a bit, as you're starting to have more people use the model, like how do we manage all that? And so a lot of it is just a workflow issue to kind of set those things up into and to be able to do that.
Yeah, one thing is, does this like impact like the core or base model, right, of a utility?
Right. Yeah, and the answer there is no. I mean, it's not. You're bringing that piece out there. One of the things I can do, though, so like we were just doing this simulation here, off this EPS simulation. If I mess around in here and I close some pipes and I change some demand conditions and I, look at a whole bunch of things, I can come in here and hit this where it says save scenario as, and let's see. I don't know, give it a name or whatever. And so I saved this scenario out. It doesn't like that. Hang on a second. If I just we'll just give it a description in here. Save out that scenario. And now what I've done is I've now created another scenario that internally could be used within Sedaru Modeling and shared. So I could be working on something and testing out this fire flow or testing out this other piece and then say, hey, Kevin, I want you to take a look at it. And then when Kevin comes and opens up Sedaru Modeling, he can come in here under scenarios and be able to pull up this scenario that I just pulled up in here and look at the same thing I was looking at and be able to run that right from there as well too.
No, that's cool. And I can see when you added it, and I can see the owners of all these. So that's
right.
Really helpful.
Exactly. So it allows you to kind of go ahead and manage some of those things. From a water quality modeling perspective, that's a lot of that's in that list of stuff that we're talking about adding. So, you heard me reference the EPA Net Engine. There's some default, there's some functionality within that EPA Net Engine around water age, water quality side of things, and some of that stuff. So a bunch of those pieces are coming. I think water age is going to be one of the next ones in there. And certainly we get into some water quality stuff, like wanting to be able to, you see like here, I'm looking up, what is we're back to sort of looking at pressures in here, right? So, or like, well, this tank level is a good example. What my tanks are doing often drives a lot of water quality issues, right, in terms of water age and some of that stuff. So a lot of the pieces are there for us to be able to jump on it and to look at water quality results and analyze that. As you get into water quality modeling, most folks don't have a terribly well calibrated water quality model. That's another sort of animal in and of itself. But certainly I can see the water age piece of it, really becoming valuable there. So, and really too, I mean, it's one of those things, much of what we do from a Sedaru side is very, very driven by the priorities of our clients. And so, the more folks that come out and tell us like, hey, I want to see water age modeling in here like tomorrow, because it's going to help change the way we do something. That's going to be something too that's going to make it easier for us to prioritize to get that functionality and get those pieces added in there. Let's see. I think, how many scenarios can you upload? I mean, there's not a physical limit on the number of scenarios that you can upload. We do like to encourage folks, like, keep it organized, because that makes your life a lot easier, right? Like if you're, just sort of willy-nilly kind of putting things in there. The Sedaru modeling tool is not meant to be the be-all, end-all modeling, for most organizations, right? You're still going to have a tool that you use for your calibration of models. Consultants are going to certainly be using those things. It's meant to be the tool to consume these completed hydraulic models and to then be able to work with them and to run those analysis internally and to not necessarily be reliant on, a single hydraulic modeler to be able to do all of your pieces in here. And there was, a question up there kind of around that too, like what's the interface for calibrating the model per se. And again, this isn't designed to be the model calibration tool per se. And I think that's some of your reference, Kevin, to sort of the cockpit, right? Like when you've got, there's a whole, the world of calibrating hydraulic models is is its own world within there. And so there are some very specific things that you need to do and look at. And so this isn't, not designed to do that. Certainly one of the things that we're doing, and I think we'll do another Sedaru Live about this, is we do have an interface that's designed all around real-time hydraulic models. And that's really one of the next phases of this. And so is really looking at, okay, so what is my tank level at when I'm running the simulation? What are my pumps doing? And we've got some of these real-time hydraulic models. You hear us reference Sedaru Ops. And that's what Sedaru Ops is our real-time hydraulic modeling interface. And it's really designed, again, same idea of non-hydraulic modelers being able to synthesize SCADA with this hydraulic model and look at a forecast and be able to see the things that are happening in the future.
Yeah, and that's cool to see, especially with you're seeing like operators. These are guys that are not hydraulic model experts at all. They're in charge of making sure that water's production and everything's kind of working as it's supposed to. But they're able to do very advanced real-time hydraulic modeling with a very simple interface that they don't have to be experts in.
Right.
And I think that's a big point of what we're showing today is this is a tool that is for all the people that don't get to use the results from the model on a day-to-day basis, but would really benefit from it. So instead of the one engineer in the back of the room that's able to run the model, now we're able to take all of the work that's been done to create, to calibrate, to validate the model, and now share that. That's hence the modeling for the masses. The point of this is to really put it in the hands of more people to really benefit from all that work that's put into it. So
Right. Absolutely. And so one of the things, so you really do, and like you said, we kind of continue. It keeps growing, right? And what we can do with the software and what some of those pieces are. So there was a question about controls. So there's some stuff I can do in here today with sort of modifying tank levels and doing some of that, and like I said, sort of how controlling pumps to turn on and off. When you get into the real-time modeling interface, there's a whole bunch of functionality built into that that's going to let me really start dialing in pump controls, because it's and seeing how those things behave and look at that stuff as well too. So we've tried to keep this as simple as possible, right? So that you have that ability for somebody with limited training to take the couple of approved scenarios that are out there and to be able to run with it, right? And to be able to look at do that analysis, say yes, no, or I don't know, I need to look at that more, right? And then have like an experienced engineer dig into it for them a little bit more.
Sure. Yeah, and I think that's another kind of real important point is this is still very much requires engineering judgment and, for someone to kind of, look at the results and allow that to still take place. However, you can still apply that and provide that to, to other folks, once that's kind of been vetted, and, that's where you have like those scenarios and you can manage all of that. And I can still, as an engineer, really get in there, geek out and do a lot of things, but we can still provide a very, simple scenario to everyone else that's kind of ready to go and provide some easy results.
Yeah. Yeah. I mean, and we do see it all the time where you see the scenario of like, hey, I'm going to do this shutdown over here. I'm going to close this pipe, and whoops. I come in here, I want to close this particular pipe, and I want to see what the results of closing that particular pipe look like, right? And that, it shouldn't be underestimated. Like, that's really hard to do right now with a lot of the tools that are out there. And so I can kind of very quickly go in and run that analysis and get it done and be able to see some of those things pretty quickly. And so I think, at your organization, folks will really enjoy that. They'll jump right over that. They'll be all over that. So,
yeah,
cool. Well, good. I had a lot of great questions out of folks. I think just so everybody knows, you'll get a follow-up email from us about this. If you want to talk specifically about, what's the requirements look like on your end for how you might want to run your hydraulic model and what you want to do there and what some of the users might look like, we're happy to kind of continue those conversations with you and help you figure any of those pieces out. Or just in general, have more questions about Sedaru and how it might help your organization, we would love to talk to you more about that.
Yeah, that was great, Adam. Appreciate the little bit of a lesson on some modeling, and got my terminology down. So I'm gonna use that and next time I'm in Cabo. So
there you go. That sounds good, man. All right, thank you everybody for joining us, and we'll talk to you again soon.
Yeah, look forward to it. Thanks, guys.
Thanks.